Welcome to my video on images of the Moon in its first quarter phase taken with my Seestar S50 Smart Telescope on January 26, 2026. This is the Seestar S50 Smart Telescope. It is a great little telescope that takes a wonderful variety of images of objects in the night sky. This is an image of the Moon taken with the Seestar S50. The Moon is in the first quarter phase with the eastern limb illuminated. The Moon is 7 to 8 days into its lunar cycle. The image shows a variety of craters and seas on the surface. More detailed images with explanations are coming up. This is the terminator area of the Moon, the line where daylight meets dark. In the picture, I set the optical zoom to 2 times to get a better view of the crating along the terminator. This northern region lies along the dramatic boundary between the rugged Apennine Mountains and the smooth plains of Mare Imbriu. The Apennines aren't volcanic mountains like on Earth. They're the uplifted rim of a colossal impact basin. Around 3.9 billion years ago, an asteroid struck here with unimaginable force, excavating the Imbriu Basin and throwing up a mountainous ring hundreds of miles long. After the impact, lava flooded the basin, cooled, and formed the dark surface we now call Mare Imbriu. Notice how flat and relatively smooth it looks compared to the heavily cratered highlands nearby. That contrast tells us the mare is younger than the surrounding terrain. Along the edge of the Apennines, you can spot sharp shadows and isolated craters that appear stretched or distorted. These formed as later impacts struck uneven ground, giving us clues about elevation and slope. This entire region is a textbook example of how impacts and volcanism shaped the Moon's surface early in its history and why the lunar terminator is the best place to see geology come alive. Here we're looking across the central portion of the Moon, where smooth volcanic plains meet some of the oldest, most heavily cratered terrain on the lunar surface. The dark area to the east is Mare Tranquillitatis, the Sea of Tranquility, formed when molten lava flooded a low-lying basin billions of years ago. Its relatively smooth appearance tells us it's younger than the surrounding highlands. Moving westward into the brighter terrain, the surface becomes densely cratered. One of the most prominent features here is the large crater Ptolomeus. Its worn, rounded rim and partially flooded floor show just how old it is. This crater has been softened by countless impacts over immense spans of time. Nearby, Albateginus stands out with sharper walls and a more defined interior, indicating it formed later than Ptolomeus. By comparing craters like these, scientists can reconstruct the Moon's history layer by layer, using crater shape and erosion as a kind of geological clock. This view takes us into the Moon's southern highlands, one of the oldest surviving landscapes in the solar system. Unlike the smooth lava plains we saw earlier, this region was never flooded by molten rock. Instead, it preserves a record of relentless bombardment, stretching back more than 4 billion years. 2 prominent craters dominate this scene, Walter and Deslandres. Walter is a classic large impact crater with steep walls and a rugged interior, while Deslandres is so heavily eroded that its rim is broken and irregular. In fact, Deslandres isn't a single crater at all. It's a complex of overlapping impacts piled on top of one another. The sheer density of craters here tells an important story. This region formed early in the Moon's history and has remained largely unchanged ever since, slowly accumulating scars from countless impacts. Every crater you see is a remnant of a violent past frozen in time. Thank you for watching.